All right, I'm on page 675, and we're going to talk about writing polynomials in standard form. Okay, so the terms of a polynomial can be written in any order, but when a polynomial contains only one variable, there's a standard form in which it can be written. Okay, so the standard form of a polynomial containing only one variable is written with the terms in order of decreasing degree. Remember, we learned how to do degrees up here. Okay, so if you write a polynomial in standard form, the highest degree term is going to come first, followed by the term with the next highest degree, etc. Okay, and when you write a polynomial in that form, then the coefficient of the first term, the coefficient that goes with the term that's got the highest degree, is going to be called your leading coefficient. All right, so for example, 5x to the fourth plus 4x squared plus x minus 2, that is a fourth degree polynomial. Why? Because x is raised to the fourth power. And it's written in standard form because we've got highest degree down to lowest degree. It consists of only one variable, x. First term is 5x to the fourth, so the leading coefficient is 5. All right, let's go to the next page. Okay, so we've got example 2a, 20x minus 4x to the third plus 1 minus 2x squared. All right, so first of all, I've got four terms. I've got a positive 20x, I've got a negative 4x to the third, I have a positive 1, and I have a negative 2x squared. Okay. All right, ooh, my pen's kind of run over the exponent there. So we need to write them in order of greatest to least degree. So negative 4x to the third is the highest degree term I've got, followed by negative 2x squared, followed by positive 20x, and last is a plus 1. Okay, because negative 4x to the third is a third degree term. This one is a second degree term. This is a first degree term, and this one's 0. Okay, the leading coefficient is negative 4 because that is the coefficient of the highest degree term. Okay, so sorry about that announcement. But anyway, we list them from greatest to least degree. So here they were in that random order. And when we write them in order of decreasing degree from left to right, then we've written them in standard form. Okay, find the degree of each term and then arrange them in descending order of their degree. Z to the third, that's the degree is 3. Negative z to the sixth, that's a sixth degree term. 4z is a first degree term. So degree 3, 6, and 1. So the highest degree term goes first. That's negative z to the sixth. And then you're going to say plus z to the third. And then finally plus 4z. Okay, which is basically, we've basically written it already in standard forms. Negative z to the sixth plus z to the third plus 4z. The leading coefficient is the coefficient on this first term with the highest degree. Well, there's no number there, but it's just like what we've done in chemistry when we did this in science. We don't write subscripts or coefficients of 1, so there's really a 1 there. So the leading coefficient is negative 1. Okay? All right, we're going to do maybe 2 of these down here for just a couple of examples. Let's do number 8. I'm looking, this one is my term with the highest degree because it's y to the 8th. 18 y to the 5th is going to be next, and this one is going to be last. So negative 3y to the 8th. The 18y to the 5th has no sign in front of it, so we assume that's positive. So plus 18y to the 5th plus 10y. Your leading coefficient is going to be negative 3. Okay. On this one, we actually have two terms right there with the same variable raised to the same power. So those are like terms and they can be combined. So I have a negative 15x and I have a positive 10x. Negative 15x plus 10x is negative 5x, so that takes care of those. And then my other term is plus 13. So my leading coefficient is negative 5. Okay. All right, and now we're going, this kind of leads us into simplifying polynomials. All right, so join me down there. Okay, so we can simplify polynomials by combining like terms, but remember, like terms are monomials that have variables, like the same variables, and those variables are raised to the same powers. Okay, so if you look down here, we have r squared plus 5r to the third plus 2r squared. Okay, these guys have the same variable raised to the same power, so they are like terms, and I can combine them. So 1r squared, essentially, plus 2r squared is going to give me 3r squared. However, this other term, 5r to the third, the r is raised to a different power, so you cannot combine it with these other two. So it's an unlike term because it's raised to a different power. All right. All right, it says to identify the like terms and combine them using the distributive property and then simplify. Okay, so this is actually the one we already just looked at. So r squared and 2r squared are both contain r raised to the same power, so you can combine those. That's 1r squared plus 2r squared, so that's going to give you 3r squared. And then this one, 5r to the third, is raised to a different power, so I can't combine it with the 3r squared. All right, let's give it a shot down here. I have negative 2y to the third minus 8y to the second plus y to the second plus 2y to the third. All right, I have negative 2y to the third, and I have another term over here that's got the same variables raised to the same power. So I can combine those. Negative 2y to the third plus 2y to the third actually cancels out, and you're going to have 0y to the third. And then let's look at the other ones. Negative 8y squared plus basically 1y squared. That's going to give us negative 7y squared, because I can combine those. Okay, these two added to 0, 0y to the third if you want to think of it that way, but it's 0. And then these two are the only things you have left at the end, and it's negative 7y squared. All right, now things are getting a little bit more complicated, but still it's not too bad. I have p squared q to the third minus 4p to the fifth q to the fourth minus 4p squared q to the third plus 3p to the fifth q to the fourth. Okay, it says first rearrange in descending order of exponents. So put it in standard form, meaning from greatest degree to least degree. Let's do that first. Okay, this one is a 9th degree, so that one's going to be the first term. Then this is also 9th degree, Those are going to be alike. And then pq to the third and negative 4p squared to the third, that's p squared to the third also. Those are like terms. Okay, so we are going to wind up having a negative, where's my pen? There you go. Negative 4 plus 3, that's going to be a negative 1 p to the fifth q to the fourth. And then we're going to combine these. This is 1 minus 4. That's going to be negative 3 of those, which is negative 3p squared q to the third. Okay? Okay, and I didn't worry about trying to fill in these blanks because, frankly, sometimes I don't know exactly what they want me to do here. Sometimes they give me more boxes than I know what to do with. But anyway, the process is put together like terms and then list them in order of decreasing degrees. So greatest degree to least degree. Okay? Okay, I'm now on page 678, and I'd like you guys to look at number 13, because at first it may look like, wow, I can't combine anything. I can't do anything with anything. Well, that's not true, because I can make it look a little different if I will go ahead and do the distributive property. So 3 times A is 3A. 3 times a positive B is 3B. And then be careful here. This is a minus 6. So minus 6 times B is minus 6b. Minus 6 or negative 6 times c is a negative 6c. Then you have a positive 8 times a, so that's a positive 8a. And a positive 8 times a negative c, so that is going to be negative 8c. So after I do that, then I can start seeing that I do have some like terms. All right. My A terms I can combine. My B terms I can combine. And my C terms I can combine. Make sure that you include the sign that goes before. Okay, so all of these are to the first degree, so I'm just going to, frankly, list them alphabetically. So these two can be combined because they're alike. Positive 3a and positive 8a, that's 11a. Positive 3b and negative 6b is going to give me negative 3b. Negative 6c and negative 8c is going to give me a negative 14c.